Okay, you guys, so now what we're going to be doing is finding an inverse. Alright, so far I've given you the two pairs of functions, and all you had to do is to test if they were inverses or not. Right, this is different because I'm actually giving you the function, and I'm asking you to actually find that inverse. So that creates a different challenge. Now again, remember what we have in terms of test, right, is we have a numerical test that we can use. Right, and we have a graphical test we can use, and we kind of see the action. We have a composition test that we can use, and it turns out, right, that these two are pretty helpful under certain conditions. And that one, it helps us prove things, but it's not really helpful in terms of finding the inverse. Okay, so that one and that one are pretty simple once we have something, because remember, the first thing I have to make sure of, in order for the inverse to exist, my function f of x has to be 1-to-1. It has to pass the vertical line test, which it does because it's a function, but more importantly, it has to pass the horizontal line test. So if we don't do that, the inverse can't be found. Right? If it does do it, then the inverse can be found. All right? And so to find that, it's a little hard to do 1-to-1. So what I'm going to do, just to speed things up for you, I will tell you whether the functions are 1-to-1 or not. All right? And of course, if I wanted to test your ability for 1-to-1, I'd probably put a calculator in your hand, because that is the best test for 1-to-1-ness, right? Is to actually look at the picture of the graph, right? Let's just do one of these, right? If I look at the graph, let me get rid of that, of, I don't want to zoom out that far. All right, so if I look at the graph of, I've got x, no, I got 2x. 2x plus 4, and dividing that by 3, right, we can see that that graph, right, actually is a line graph, so it clearly passes both the vertical line test because it's a function, but it also passes the horizontal line test. So this is truly a 1-to-1 function. I should be able to find the inverse. Even that cubed root graph, let me take that off and bring that back up. So if we took 2 minus x, and I now raise that to the 1/3 power, right, what I get is this graph right here. Let me zoom in, and you can see that that graph does in fact pass the vertical line test, right? It should, because it's a function, but it also passes the horizontal line test, right, making it a 1-to-1 function. So again, if I was asking you to find if something's 1-to-1, I'd put a calculator in your hand, especially at this point of the semester. Otherwise, I'm going to tell you they're 1-to-1 and just tell you to get the job done, right? So find the inverse. So how do we do this? All right, well, if the function is a table like I have here, I guess I have A, B, C, and D repeated. So the A, B, C, D, E, this should be E and F. I'm sorry about that. So this is a 1-to-1 function. Well, numerically, what's supposed to happen? The x's and y's are supposed to flip-flop. So this actually is very easy to find. So the inverse function, right, would be another data table, but all we have to do is flip-flop the ordered pairs. Alright, so there would be the inverse for that function right there, because it's given as a table of values, and we know our numerical test, right, we just flip-flop them and we've got it. So since the function's a table, that means the inverses have to be a table. The graph, right, what do we know about the graph? Right, well, clearly this is a 1-to-1 function, right, passes the vertical line test and horizontal line test, and to find out whether it's to find the inverse, right, so here, let me put it in black, is f of x, right? Well, what I do know is that I got to draw that line y equals x, which would be where all the x and y values are equal. So there's y equals x. So I'm expecting this graph to basically reflect around it. Or what I can do, if I wanted to be real good, is just take some ordered pairs, right? So there's 0, 1 seems to be on the graph, 1, 2 seems to be on the graph, 2, 4 seems to be on the graph, and how about we call that -1, and like a half seems to be on the graph. So if I just replotted these points, right, 2, 4 gives us 4, 2, right, 2, 1, or excuse me, 1, 2 gives us 2, 1, 0, 1 gives us 1, 0, and half negative 1 gives us that. So I'm expecting this graph, right? There would be a picture of the inverse function given that graph. So I'm just making use of, in terms of finding these two inverse functions, I'm just making use of our test. Numerically, we know that the ordered pairs flip-flop. Visually, not only do the ordered pairs flip-flop, but they're a reflection through the line y equals x. So I got those two down. But now the challenge is what happens if the function is already, right, a equation? Then I expect the inverse, when we find it, to be another equation, right? Not a table, not a not this. Even though we could probably go visually, numerically do that. But how do we find the inverse? So here's what we're going to do, right? What we're going to start doing, step 1, if you want a step-by-step process, is you're going to start by replacing the f of x, with y. Now that's not really a big stretch because we've been using, right? That's what f of x is. It is y. And then step 2, what you're now going to do is in your new equation, you're going to flip-flop x and y. And that's major here. As a matter of fact, I'm going to put a line here because what you now have, right, in step 3 after that flip-flop, you are actually looking at the inverse, right? But what's going to happen, step 4, as you'll see, is we're going to have to solve for y. And that'll be clear when I go there. But as soon as I do a flip-flop, right, numerically we know when we flip-flop the roles of x and y, I'm now dealing with an inverse situation. And so the equation is going to change. It's now the inverse, but we're going to have to solve it for y, as you will see. So let's see this in practice. So to start this, to find this guy's inverse, I'm going to start by letting y, right, replace the f of x. No stretch of the imagination there because that is what f of x is in the first place. It's just y. But here's the new thing, and I'm going to change my pen color, right? I'm now, right, this y I'm going to change to x. This x I'm going to change to y. And so at that stage of the game, notice these equations are different, right? Because of the flip-flop of the x and y, we have very different, all right, equations. So the one in black upstairs is f of x. The one downstairs is the inverse situation. But here's why you have to do the fourth step. I want my inverse to be a function of x. And right now my inverse, right, x is in terms of y. So I want my inverse to also be a function of x, so I can do this type of comparison graphically. So that is why this 4 steps there, we have to use our algebra to solve for x. So let me change colors. Let me go to blue. So to solve for x here, probably a good first step is to multiply both sides by 3. Right? That'll clear the 3's out, and that leaves us with 3x equals 2y plus 4. Right? My next move will be to subtract 4. So we get 2y equals 3x minus 4. If we divide everybody by 2, we get y equals, I think that's 3 halves x minus 2. So what's the inverse in this situation? Let me go back to red. The inverse function here, right, is 3 halves x minus 2. All right, and so how do I verify that? We got 2 ways to verify it, right? One is to actually go do the compositions, but I'm going to save myself some time here. How about we just go look at the graph? So my function f, I erased it like a dummy, is 2x plus 4, right, over 3. So there's that line. And then the other line that we found, the inverse, is the fraction 3 over 2x minus 2. And then just to be official, let me go ahead and put the line y equals x in there. Okay, and so when I do go graph this, right, here's basically the graph over here, and you do see that those graphs do appear, right? They kind of coincide along that line, and then this line up here, I got my colors mixed up. The y equals x is that kind of greenish blue line, and so there's the two functions, and they do reflect each other through the line y equals x. So it looks like we basically nailed it. Alright, so there's how you find the inverse. I got 3 more to do. I'm going to cut to another video. But again, if you have a table of values, you just flip-flop the tables, you got your inverse. If you have a graph, you reflect it through the line y equals x, or you just take your data and reverse the data, and you got your inverse. If you have an equation, you go through this step-by-step process. You replace y, you replace the f of x with y, you flip-flop the roles of x and y, you now have the inverse, but you have to now solve it for y so that we get our inverse as a function of x. And that's basically the steps. Alright, so I got 3 more to do, but I'm going to cut away to a new video, and we'll do that together coming soon.